All right.
I do have my check.
Yeah, he didn't either.
I don't want to.
You were gonna ask me. You don't tell me anyways. You know that every so basic, you can log into the Snapchat on the website.
All right, so here we go. Sorry.
What'd you say?
Now, angles and unit circle. We have talked about angles. Okay, you've talked about angles. And angles are, most of the time when you're talking about the shape, we only talk about angles from what measure to what measure? From what to what? Yeah, what starting point, what ending point? Common sense, guys, on this. Angles. What measurements are they? From 0 to 180. That's usually the way we talk about it, from 0 to 180. And mostly it's because 0 to 180, it would be like this room. If the angle got more than 180, you would no longer be in the room. Where would you be? Outside the room. Okay? To enclose a place, the angles are less than 180, and after you put enough angles that are less than 180 together, it ends up enclosing something. Does that make sense? Most of the time for us, it's a room, and it has four corners that are what? 90 degrees. Okay? So, most of the time up to this point, we've only talked about angles from 0 to 180 degrees. Because that's usually the way the physical angle is associated with the angle itself. That's the way we look at it, is between 0 and 180. What we're going to be getting into is the curvature of a circle. Now, when we get into that, more than 180 is an applicable thing. All right? Do a 360. What does that mean? Turn all the way around. Well, you're not necessarily talking about the angle. You're talking about the all the way around spin. Does that make sense? Not an angle, but the spin of all the way around. That's what we're approaching. We usually don't associate it with a physical pointed angle. We're talking about the curvature when we talk about bigger than 180. However, the angle itself and the arc, the loop around, they're closely related to one another, and that's what we're getting into. Okay? Now, before we can do that, we need to talk about some of these terms: standard position, initial side, terminal side. Standard position means that the angle is positioned on the XY plane with the vertex of the angle at the origin and one of the sides on the x-axis, going from origin to the right. Okay, that's standard position. The other side can be wherever it ends up. That side that is on the x-axis, starting in the origin and going right on the x-axis, is called the initial side, or where it starts. Initial, how you start something. The other side of the angle is the terminal side. In other words, that's where the angle stops. Does that make sense? Okay? And the arrow that's drawn inside tells you which direction you're going to go to get from initial side to terminal side. This one is saying to go counterclockwise from initial side to terminal side. I could add my own arrow in this one. In the black arrow, the black dotted line arrow there says go clockwise from initial side to terminal side. Okay? So the arrow in there means something. Does anybody have a question about standard position? We're talking about initial side, talking about terminal side. That's pretty easy stuff, right? Okay. That brings us to this next thing where we was talking about clockwise and counterclockwise a minute ago. Counterclockwise is the positive measurement of the angle. Going counterclockwise to measure an angle is going in the positive direction. Counterclockwise is going in, clockwise is the negative direction, counterclockwise is the positive direction. Everybody with me? Does everybody understand what counterclockwise and clockwise mean? Counterclockwise, why do they call it counterclockwise? It's going away from the way the clock spins. The clock turns a right, down, up motion. Okay, counterclockwise is moving to the left. Okay, so if an angle moves to the left, that's a positive degree measurement. If an angle goes clockwise, that's a negative degree measurement. Is everybody with me on that? Okay, and you indicate which way it goes based on the little arrows and which side they're drawn on, whether it be drawn to the left, which is counterclockwise, or to the right, which is clockwise. Everybody good with that? Okay. Notice that a positive 120 degree angle and a negative 120 degree angle end up in two different places. Their initial side, it's standard form because they're at the origin. One side's on the x-axis, but the terminal side where it ends is in different places depending on whether it's negative or whether it's positive. Is everybody good with that? Okay? Okay. Now, measuring angles in standard position. We're not going to pull out a protractor out here and measure this. We're going to use a little bit of past knowledge, and we're going to come up with what we realize the angle measure would be. Okay? So for instance, like in A here, what is it that they're expecting you to remember from the past about why is it 90 degrees?
Because it's a right angle and it's going counterclockwise.
How do you know it's a right angle?
Because both of them are on one of the axes.
The axes are understood to be perpendicular. That's right. They're understood to be perpendicular. So because we know this is an angle in the XY plane, we are going on past knowledge that we know. The axes are perpendicular. If they're perpendicular, that means they form right angles. Well, if they form right angles, that means their measure is 90 degrees. The way this arrow is drawn is telling me I'm measuring this angle which way? Counterclockwise. So it will be positive 90 degrees. Does that make sense? Now I can use that for the other compartments of the four locations in the four quadrants. If that's 90 degrees, how much is that? This part right over here, how much would that be? Well, how much would it all together be? 180. And if I wanted to go from here to here, what would I do? Add another 90. So from here all the way to there, draw it so you can see it. From there all the way to there would be 270. Does everybody see how this works? This is the part I'm trying to get you to see. Okay? Everybody good with that? All right, now, this one over here, B. It's significant that they give you a coordinate that has both the X and the Y the same. Why is that important? What does it mean if the X and the Y are the same? What equation, a line, will make the X and Y the same? Well, that's Pythagorean theorem. Real easy. You're making it way harder than it needs to be. What equation of a line says the x and the y's are the same? Y equals, well, not the mx plus b part, just y equals x. So that point would be on the line that is y equals x. Well, if I extend that right here, what's significant about that line? What's it doing to those quadrants? It's bisecting, exactly. What does bisecting mean? Cutting it in half. So going back to what I know over here in A, if from there to there is 90 degrees, and this line's cutting that in half, bisecting it, what does that mean? .45's right. So that would have to be 45 degrees. That would have to be 45 degrees. Why is that of any use for me doing that up here? The angle I want's down here in the other quadrant. It's going to be doing the same thing down here, exactly. It's going to be cutting that in half too, so that would be 45 and that would be 45. So they're wanting me to get an angle from here to here. What would its measurement be? How would I find it? Say it again. 90 and 45, exactly. From here to here is minus 90, and from there to there, and going in the same direction is minus 45. When I put them together, what do you get? Negative 135, which is what they got. Does that make sense? Does everybody see how this works? Please don't make this hard. We good with that? Any questions or problems with that? So do this one. Has anybody got the first one yet? You already have that one already. How do you know it's 45? How do you know it's cut in the middle? Huh? Goes all the way across is 90. What does that have to do with that being 45 degrees?
Because if you extend that line of 3, it's a bicycle.
Finish, Gary.
I guess the 3 and 3.
What about the 3 and the 3?
It's the angle between the line and
If the x and the y's are the same in the coordinate, that means it has to be on y equals x, which is understood to be bisecting the angle. Does that make sense? Well, if it's bisecting, that's 90, then that has to be 45. Now, you're not going to have to give that verbal description every single time. I want to make sure that y'all understand that. So whenever, if they give me a coordinate right here on these, which coordinate had they better be giving me? As long as they're the same, that's right. 4 and 4, negative 2 and negative 2, negative 12 and negative 12, 2.8 and 2.8. As long as they're giving you coordinates that are the same for the x and the y, that means it's on the line y equals x, which means it's cutting the 90-degree angle in half. Everybody with me on that? All right, this one down here, what are you going to do with it?
You're going to add the 390 degrees.
Add 390 degrees. Is that right?
It'd be negative 90.
Negative 90s, yes. Negative 90s. Why?
Because it's going clockwise.
Because it's going clockwise, which is, so what would the angle measure be? Negative 207 degrees. Put the little degree symbol on there. Make sure you say degrees. Everybody with me on that? It's important, it's very important now that we start representing that it's degrees, because we're fixing eventually to get in another way, another measurement of angles in radians. We're not going to get to it today, but there's 2 different ways, which is why your calculator has that mode setting that you have to pick. So make sure that your modes on your calculators are in the right radians or degrees depending. Everybody good with this? Okay? sketching angles. We're not going to get out a protractor and draw them perfect. This is asking you or wanting you to get a comprehension of angles and get close. Sketching. We're not going to be perfect. Okay? So if I'm sketching and I want to sketch a 36-degree angle, describe to me how you would do that. Better than just say guess. That's not going to cut it. In the end, it basically comes down to a guess, but there's some things you can do that helps your guess. What is it that you can do right there to draw a 36-degree angle?
Well, you know, if half of it is 45, and you know 36 is smaller than 45, then you're going to go a little bit under a half.
There you go. Perfect. Well, she said, you know that 45-degree angles is bisecting. 45-degree angle will be right down the middle. 36 degrees is a little less than that. So back off of 45 degrees just a little bit and draw your 36-degree angle. Perfect. What's another way to do it? What's another angle that we've talked about quite a bit that's here, or that is close to what we're talking about? We got special cases for them. 30, 60s, 90s, and 45s, right? We have 45, 45, 90 triangles, 30, 60, 90 triangles. What's the significance about a 30-degree angle? How can we use that with this 90-degree angle? What's the relationship between the two? 30 degrees is what? What part of 90? Huh? A third. 90 is a third of, 30 is a third of 90. So if I were to divide that into 3 equal parts, each part would be 30 degrees. Does that make sense? Well, 30 degrees, 36 is a little bit bigger than 30, so I could go a little more than 30 and get 36. Does that make sense? So there's 2 different ways that you could do this problem. Okay? Either one of them is fine. I mentioned the 30-degree angle for a reason. It's something that appears a lot. Okay? So there's some angle measures that we should know, even though we don't have protractors necessarily on this. First of all, 0 degrees. That's easy. Right? So some angle measurements we should know. 0 degrees. Where's 0 degrees? No angle, just a ray that goes from the origin out. Angles that we could come up with on our own. 30-degree angles by dividing 90 into thirds. I can put 2 30s together and get what? 60. Take the 90 and divide it by 2, get 45s. The 90s, put 2 90s together, what do you get? 180, go all the way around, what do you get? So right there is a list of some angle measures that we ought to be able to come up with without our protractor on here. Would you agree with that? And that's what you're going to be doing here. To do these things, you're going to take these that you can basically kind of come up with on your own and get as close as you can to what you're looking for. 315. How would you draw 315? Is it halfway?
No, you try to get that and then see if it's in farther than that.
Well, how much farther? You said from here to here is 270, right? From the initial side to right here is 270. Then what?
But you found the halfway distance
I don't know. Why would you want to find the halfway distance?
to see if that goes farther or put it in before.
Well, from 270, how do I get to 315? Why don't you do 315 minus 270? What do you get? 45. So in other words, if I go to 270 and then add 45 more, I will be at 315. Does everybody see what we're talking about? Say something. So 270 and then go halfway again. So there we go, 315. What about negative 150? How would you get to negative 150? What's an angle measure that ought to be jumping off just screaming at you about negative 150? Negative 180, going clockwise 180 degrees. So from here to here is negative 180, right? What other angle measure ought to be screaming at you right here because you know how to add and subtract? 30 degrees. 150 is 30 degrees from 180. So back off a third below the, right? Back off a third right here, 30 degrees. So when I put it all together, the red mark there, negative 150 degrees. Does that make sense? See how y'all put those together? Again, are these going to be perfect? No, they're not supposed to be perfect. We are sketching the graph. Okay? So sketch those real quick. Go. A 100-degree angle and a negative 215. All right, so this 100-degree angle, which one are we going to get real close to? Or which one are we going to key off of to get our 100? 90. Yeah, 90 is real close to 100. Where's 100 going to be from 90? Not one. 10 more. All right. Which way are we going to move with it? Counterclockwise. How do you know? Because it's positive. So my initial side is going to be the x-axis down here. Right? And I'm going to move counterclockwise. I just need to figure out where am I going to stop. Well, 90 is, or excuse me, 100 is 10 more than 90. So if all the way up to the y-axis there would be 90 degrees, then I'm going to need to go about 10 more 100 degrees. Is that perfect? Of course not. It's not perfect. It's close. We good? Negative 210.
15, but it's just
What to do? Negative 250. You started to say how far?
Oh, I did, go, it's negative, so that means you need to
Go which way?
clockwise.
Clockwise.
Yes.
All right, so we're going to start on the x-axis right there, and we're going to go that way with it because it's negative. What's some angles that I can go ahead and go right off the bat? 180. I can definitely go 180. 180 is all the way over to here. I need to keep going though. How much? 35 more. Well, which is it? No, it ain't. It's more. Yeah, but the number itself, 215 is bigger.
Yeah, that's fine.
So you got to go 35 beyond the negative 180. You need to go to negative 215. Well, how do you get to the negative 35 more? Which way? Well, in my mind, I'm thinking of 30 more degrees right there and a little over 30 degrees. You with me? So in my mind, I picture how 30 degrees thirds it, go a little more than 30 degrees, so that from there to there, all told, put together, 100, negative 180, and 30 And then my best guess at what 5 degrees would be, put it all together, is negative 215. So there's my best estimate of 215, negative 215. Can you handle that easy stuff?
Oh, yeah.
Okay. Now, the concept of coterminal angles. The nature that you're going around in a circle is I can spin around one time and I end back where I started. So how often does things start repeating?
After every time.
Which is 360. So every 360 degrees, you start repeating. Okay? We'll put that in here in just a second. Right now, coterminal angles that they're talking about is an angle measure that's between 0 and 360, the positive counterclockwise angle. In this case, the one they're using is 135 degrees. You can immediately find its negative counterpart by doing what? So really, what can you do? Subtract from 360. So 135 minus 360 gives me what? Negative 225. By the same token, if you have the negative clockwise direction angle, what can you do to find its positive counterpart? Add 360. So negative 225 plus 360 is positive 135 degrees. Does everybody understand that part? Coterminal angles. If you have an angle that's between 0 and positive 360, and I say 0 and positive 360 because that means it hasn't gone all the way around yet. Or an angle that's between 0 and negative 360, again because it will not have gone all the way around in the clockwise position yet. Does that make sense? You can find its positive or negative coterminal simply by doing the opposite of what it is. If it's a negative angle, add 360. If it's the positive angle, subtract 360, and you can find its counterpart. Does that make sense? All right. The next thing is I can find other positive angles that goes with 135 by doing what? Adding how much? What would bring me back around to here? 30 won't bring me back to here. What brings me back to here? 360. So that any positive counterclockwise between 0 and 360 angle, you can find another coterminal angle with it by simply adding 360. So the black one there says 135 degrees, the red arc, 135 plus 360, what do you get? 590? No, it's 490? 490? So the black angle there is 490 degrees. I can find, I'll use orange. I can find the orange angle there. So there's one extra trip around. So what do I do this time? Add 360 and then add 360 again. What do you get? So So 135 plus 360 plus 360 is how much? 855. So 135 degrees, 490 degrees, and 855 degrees are all coterminal angles. Does that make sense? Negative 225 is a coterminal angle with all these. I could subtract another 360 from negative 225. What do you get? Negative 225 minus 360. What do you get? Help me, guys. Negative 225, 225, not 55. Negative 225 minus 360. What do you get? Negative 585. So negative 585 in the clockwise direction also ends up in the same spot. Are you with me? How do you indicate which one of these angles we're talking about? You indicate it by the number of loops that you're drawing around to create your angle. Does that make sense? Okay? 2 loops around means you add 360 twice to the angle that you've got. All of these angle measures that's on the board are coterminal because they start at the same spot and their terminal side stops in the same direction. Pretty easy stuff. All right, then. Multiple choice. Which of the following angles is not coterminal with any of the other 3? Now, in my opinion, the way that they're illustrating it for you right here is the hardest way to do it. If I was you, I would take the angles and get them to an angle that is between a positive 0, 360. Any angle on the coordinate plane, you can get it between 0 and 360 simply by adding or subtracting 360. Does that make sense? Do I need to do anything to 300? No, why not? It's between 0 and 360. I wish that would quit popping up there. What about negative 60?
Yes, because it's not.
It's not between. So what do I do to find out 360? So negative 60 and add 360. What do you get?
300.
300. So this is an angle that's outside of the 0 to 360 range, and I was able to show that this angle I could turn into that angle, right? So right now, those 2 are coterminal. You with me? Now let's go to 60 degrees. Anything I need to do with it? It's in between. So is there any way that 60 degrees and 300 degrees could be coterminal? No, because I'm not able to get them to be the same amount by adding or subtracting 360. Does that make sense? All right, let's go and do the negative 420.
That's not.
What do I need to do with 420?
Add like 360.
Negative 420, and I'm going to add 360. If I add 360 to 420, what do you get?
The 180, 120.
I don't know. Type in your calculator.
I mean,
Negative 60. Negative 60. Is it between 0 and 360? So what do I do? Add 360 again. Yes, add 360 again. And what do you get? 300. So I was able to take D, B, and A And every one of them, I was able to show that they would be coterminal with a 300-degree angle. Does that make sense? So, which is not coterminal? The answer is C. C is not coterminal. There's no way I can make it the same angle as the other one just by looping it or unlooping it around the origin. Does that make sense? All right then. Let's see if you can do this one. Which of the following angles is not coterminal with the other three? Which of these angles is not coterminal with the other three? All right, so which one of the, let's start with A. What are you going to do with A? Subtract 360, because what do we want to try to change each of these into? The same angle that is where? Between what? 0 and 360. So 750 and subtract 360 from it, what do you get? 390? Well, what do I need to do? It's still not between 0 and 360, so do what? Subtract 360 again, and I'm able to change 750 into what angle?
30?
30-degree angle. All right, let's slide over to choice B. Do I need to do anything with it?
No.
How come? It's between 0 and 360. Well, 30 and 30. So that right now I've shown that A and B are coterminal. Now I'll go to negative 330. What about it?
Add 360.
I need to add 360. So negative 330 and add 360 to it. What do you get?
30.
30?
Yeah.
Positive 30. So negative 330 is coterminal with 30, which eliminates which choice?
Maybe in 2. I mean,
So D's the answer. Well, I don't even have to do D, because I just want to know which of the following angles is not coterminal. Well, I just showed that all three of those are coterminal. Now let's go ahead and do D just for the heck of it. So I have negative 540. What do I need to do to it?
add 360.
Add 360. Well, if I add 360, what do you get? Negative 540 plus 360.
Negative 180.
Negative 180. Still, it's not between 0 and 360, so add 360 again. What do you get?
180.
Well, obviously, 180 is not the same as the 30s.
You can't get 30.
So that one is not coterminal with the other three. You have it?
Yes.
Please don't make this hard. Yes.
I think I forgot something in the back there.
Anybody have a question on anything? Pretty easy stuff? All right, then. Your assignment is page 832. And we're going to do 7 through 25 all. All right, so that's your time. Hope the videos help.